Okie dokie. This problem is very much an extension of 442A, so feel free to check out that video or master those problems first before moving on to this one. This one asks, determine which graph has only one such asymptote, and that is x equals -2. Anytime you see x equals some number represents a vertical line. So in this case, talking asymptotes, it represents a vertical asymptote, namely one we should see at -2. X equals -2. So we're looking for a vertical asymptote at x equals -2. So just like that, number 1 looks pretty good. Let's just check the others. -2, no, 2 does not look good there. And then number 3, -2 has nothing special going on. So it looks like graph 1. Oh, they got me. All right, 1 is not our answer. Why is 1 not our answer? Pay close attention. They say examine the vertical and horizontal. And they say which one has just one asymptote. All right, so it does have the one vertical, but the language is very particular because they only want one, either vertical or horizontal asymptote. And this one actually has a vertical at x equals -2, but also has a horizontal at y equals 1. Sorry, that's messed up. There we go. Y equals 1. So it has two such asymptotes, and they are only looking for one that has the one vertical at -2. And so in this case, none have just one vertical asymptote, or one asymptote, and that is a vertical one at -2. So use this as a learning experience on my behalf. So let's do 3 more examples. Examine the vertical and horizontal asymptotes. Find the graph that has only one such asymptote at y equals -2. When you have y equals, that represents a horizontal asymptote. So at -2, we're looking at this. So -2, okay. So remember, the question we want to ask ourselves is, does the function level off at some y value of -2, either to the left or to the right? And in this case, 1's looking pretty good. And 1 also does not have any vertical asymptotes, no splits in the graph. Number 2, I mean, this function's just doing its own thing. There's no asymptotes at all in this case. There's no leveling out. There's no splits in the graph, whatever. 2 is out of here. Number 3 has the horizontal at y equals -2. However, it also has the vertical asymptote at, I don't know, x equals -1. And so the only graph that has just one asymptote, y equals -2, is number 1. Let's do 2 more examples. We're looking for a graph that has 2 asymptotes, a vertical one at -1, and a horizontal at -2. All right, 1 looks pretty good. Can we eliminate the others? It looks like 2 also has a horizontal at 4, in addition to the horizontal it does in fact have at -2, but we don't want 1 at 4. And then 3 doesn't have any asymptotes. It's a little crazy. So it looks like number 1 is our answer. Let's go ahead and do 1 more. This one is asking for 4 asymptotes, including these 2. So we want to see these 2, but we also want to see 2 more, because they say 4 asymptotes total. So usually these are easy to identify as long as it's there. It should usually look like number 1 here. So let's talk through it. Y equals 2 is the horizontal over here, because the y value is leveling off at 2. And it also has the horizontal at -4. So we have 2 horizontals so far. And then x equals -1 is a vertical at -1. X equals -1. And it looks like it also has one at +1. Whoops, sorry. +1. And so 4 total asymptotes at 2. So y equals 2, y equals -4, and then x equals -1, and x equals 1. So 1 is our answer once again. All right. I hope you enjoyed these different examples. I hope this was helpful. If you have any questions on anything you might see in these questions, please let me know.